Okay, student, today we go on our lesson. There's a 4.3 transistor. So for this part, I just go to the part 1 first. So the application, I will go to the next one. Okay, let me start our lesson. Okay, so the first one, we're going to see the lesson 4.3, understanding the transistor. Okay, so this one is refer your notes. Okay, first one, I go to introduction for the type of the transistor. We got two types. One we call NPN. So this one transistor actually is a diode. Then they add one more semiconductor. So another one is a PNP transistor. So this one is a component. So if you build about NPN transistor, normally the center one, there's a more thinner. So we got to introduce the N. One part we call emitter. Another part N we call collector. Then the center is a base. So another type is a PNP. So about the name should be the same. Emitter, base, and collector should be the same. Center, the small part, sure we call base. Okay, so from here the base, let's see the function. The base, they want to control the flow of the charge carries from the E to C. From E go to C, so they pass through the base. So the base just like the center part. Okay, collector is receive the charge carriers from the E. So that means the charge is start from the E, pass the B, and last one is C. C will collect the charge. Okay, emitter. Emitter is a supply. They supply the charge carriers to the C. So that means the biggest one sure is an emitter lah, because there's a supplier. Okay, then we go to the next one. Okay, this one is a structure. Okay, and also the symbol, how to draw in the circuit. Okay, let's see the type first one, NPN. So you see the center P becomes smaller. So this one is a symbol. Okay, one of the circle. Then you draw this one is a base. After that, you got arrow. The arrow point down. So this one is an emitter. Then up, this one is a collector. So that means you can see the arrow, how the current to flow. Base current to flow. Collector current to flow. So all will meet at the emitter current. So from here, the emitter current is collect all the current from the collector and also the base. So that means emitter is the biggest part to collect all the current. Okay, so the next one is a PNP. When PNP, can you find it? The symbol, the arrow is reverse. Okay, reverse. So from here, this one, when the arrow come down, we can say they are correct all the current, then go to the emitter. So this part, when the arrow is up, means emitter is a supplier. They supply all the current up until go to the collector. Okay, so this one just reverse of the arrow. So how we go to memorize the arrow? Okay, when you find it to go out, so we're using the NPN to represent. Okay, N stands for never. P, point. Okay, after that in, IN, the N stand for another N. So from here, you just remember, never point in. Never point in means point out lah. So that means this one is an NPN. Okay, never point in. So that's an NPN. Okay, so this one is a PNP. PNP is a point in permanently. So this one is point. This one is in. This one is permanently. So that means they always point in. So we're using this one to memorize. Never point in. Another one is point in permanently. Okay, so when you see the arrow means emitter, they collect all the current. After that, they go to separate to the base. Then they go to separate to the collector. Okay, but I want you to see one more is a part for the area. Can you see the base current is a small area? The collector current is the biggest area. So that means later we will go through why the base current will small area, then the collector current become the biggest area. Okay, for the PNP also same. The base current is a small arrow, then you see the collector, they get more current. Okay, So this one is a transistor. So this one is a component. Can you see got 3 of the leg here? Okay, this one is a component for the transistor. Okay, now we're going to see this one. This one is one of the video to show where is the transistor. Okay, normally they're inside the handphone. Okay, so this one got 2 million of the transistor inside the one part of the handphone. So this one is a transistor. Okay, now we're going to see the function of the transistor. First one, they say to amplify the current, or you can say there's a switch. So that means transistor got 2 functions. One is amplify, make the current become bigger. Another one, they become the switch, automatic switch. So from here, we want to go introduce the circuit of the transistor. Okay, transistor only can be worked when they combine with other electronic devices. So transistor cannot function if they're just one of the component. So they need to join the others. So from here, they need to join resistance. Okay, another one, they need to join about power supply. Okay, after combine, we call it transistor circuit. Okay, now we got 2 types of the transistor circuit. One is a transistor circuit 1. We need 2 battery, 2 cell. Okay, another one is a transistor circuit 2. That means we're just using one of the battery. Okay, so this one is one of the diagram where we join about the transistor with the resistance and also the battery. So this one we call transistor circuit. Okay, let's see this one diagram. We can see we got one of the battery at the base circuit. This part we call base circuit. This part we call collector circuit. So we got one of the battery here. Here is another battery. So this one is a transistor circuit. Then we put one of the resistor here, another resistor 2 also here. So the center is a transistor. That means the transistor, they want to combine 2 circuits together. Okay, then we go through transistor circuit 1 and transistor circuit 2. Okay, so this one is a transistor circuit 1. Need 2 cell, need 2 battery. So you can see the design. The design is a 1.5 story house. Okay, the lower part, they're using one of the battery. The higher part, the bigger building, they're also using another battery. So that means the current actually how to flow. The current from the E1, they start to flow to R1, go to B, then go to E and come back. So this one we call base current. So base current is not related with the collector part. That's an independence. Okay, now we go to the collector part. Collector part means the current start to flow, go to R2, then go to C, then after that go to E and come back. So that means they're just touching about the C and also the E. So this part we call collector circuit. Okay, so this one is why we're using 2 battery. If I'm using one of the battery for the base, that means collector cannot function. If I'm using collector one of the battery, base cannot function. Okay, because the collector current cannot go in the B and go back. No, collector current cannot go to the base. They just go straight, follow the arrow, go to the E only. Okay, now we go to introduce. BE is a base circuit. There's an input. CE is a collector circuit. Okay, now IB and IC. IB is a base current, collector current, then R1. R1 is in the base circuit. So the question always will ask, what is the function for R1? So your answer should be to limit base current. Okay, remember to limit the base current. Do not let 2 current pass through the transistor. So how about the R2? R2 also same. They want to limit the collector current. So E1 is the supply, battery 1. Okay, Okay, now we go and see the transistor circuit 2. This one they're using 2 of the battery. Okay, why the double story they need to using the 2 battery? Okay, let's see here. Okay, this one is a positive terminal. Okay, remember this part collector. Collector is a, this one is a never point in, is it? This one is a NPN. So this one is a N semiconductor. So N semiconductor and positive terminal, actually this part is a reverse bias. So that means the current cannot go through to the collector circuit when static. So they must go to another way. When they go to another way means they go to the base. Okay, when they go to the base, okay, when the base they function, then last part collector current can be flow. So from here actually we need to know this one battery, they want to supply to the base first. Then the base current, they go to trigger the transistor, and last the collector current flow to the collector circuit. So that's why double story, they're just using one of the battery. Okay, if single 1.5 story, if I'm using one of the battery, base current cannot function. If the base current cannot function, then the collector circuit also cannot function. So from here you must remember, for the first circuit, there's a 1.5 story, you are using 2 battery. From the double story, you're just using 1 battery, that will be enough. So you must know the first current where they go to the base first. Okay, now we're going to see this part. Okay, from starting they said overall is a 6 volt. Okay, overall to 6 volt. So from here we can say R1, R2, this part is called it battery voltage. There's a voltage divider. So 6 volt is supplied to the R1 and also R2. But they supply how many we don't know. They must depend on the resistance. Okay, we can say this one is a V1, this one is a V2. So V actually is equal V1 plus V2. Okay, so this one called base voltage. This one is the overall voltage we add together. So if we want to find the V1 and V2, we must using the voltage divider, the formula, remember? So V1 equal R1 over R1 plus R2 multiply the V. Okay, if I'm using this circuit, okay, V1 is how many we don't know. R1 is how many? R1 is a 10k ohm. Okay, R1 plus R2 means a 10k ohm lah, 20 kilo ohm multiply with the 6 volt. So you can find the V1. Okay, V2 also the same. If you're using the volt 2, so that means R2. You must using the resistance start with the R2, then R1 plus R2, then multiply with the volt. Okay, so this one is a voltage divider formula. Okay, let's see the example 1. Example 1, they show about the double story. There's a transistor circuit. They're just using one of the battery. Okay, now we're going to see the detail. They see the resistance P has 10 kilo ohm. Okay, the Q we don't know. So you want to order to light up the bulb, at least the potential difference passed through the P is a 2 volt. So that means just 1 volt they also cannot be light up. Okay, if I say P is a 2 volt, so understood the Q is 4 volt. If you want to light up the bulb lah. So from here they ask you what is the maximum value from the resistor Q. So when the bulb to light up. So they just want to find the R1 lah. So we write the info first. So the info, the first one, P is a 10k. Okay, VP, voltage passed through the P at least is 2 volt. So VQ, we know there's a 4 volt. Okay, now we need to find is the resistance for the Q. So remember what we need to use, voltage divider. So from here we find it, there's a V2 lah, VQ lah, that means easy to find. Because VQ, we know there's a 4 volt. You want to find the VP equal how many also can. You want to using the VQ equal how many also can. Because both also got RQ. Both also got R1. So I find it if I using the VP, that's a more easier. Because VP equal RP over RP plus RQ. They just got 1 RQ. So I easy to find it. So I show you here. So I using VP. So Vp, we must take Rp first, over Rq plus Rp multiplied with the 6. 6 is a total volt. So 2 is a Vp. So this one is a 10 kilo. Rq plus 10 kilo multiplied 6. So after that, this one Rq plus 10, I go up. So this one 6 multiplied 10 becomes 60. Okay, so from here I find it. 2, I bring here. As using the 60 over 2, they become 30. So from here, I want to find RQ. 30 minus 10. So that's equal to the 20 kilo ohm. So finally, I make a conclusion. Resistance for the Q is 20 kilo ohm. For the P is just now from the P, there's a 10 kilo ohm. Okay, so this one is the resistance, Q and also the P. The volt is a voltage divider. Vp is a 2. You want to light the bulb. So VQ is how many? VQ left is a 4 voltage. Okay, so this one's one of the calculation. Okay, let's see this one video. They show about the transistor. Okay, the working of the transistor like this. The current will start to flow to base. After that, go to the collector. Okay, we just see about the joint. This part is a base. Okay, this part is a base. Then this part is a collector. So that means they will start from the base first. After that, go to the collector. Okay, later we explain about the details. Okay, how the current flow in transistor. So this one diagram already inside your notes. Okay, we go and see the base part first. This one is a base. Okay, they say a few of the electrons will flow through the base. So from here they start current from the positive to negative. They flow through the R1, go to the P type, then go to the N type. After that, go back. Okay, the outside the arrow stand current. Okay, the inside the small current stand for electron how to move. So this part actually is a forward bias. Okay, forward bias because P type join with the positive terminal. Then the N type they join with the negative terminal. So for this part actually is a no problem. The current can be flow because you are forward bias. Okay, now I want you to see is the second part for the collector part. Okay, this one is a positive terminal. Okay, this one is a negative. There's an N type. Suppose collector circuit when starting there's a reverse bias. So that's why when starting the collector circuit is cannot function because there's a reverse bias. They need to wait the base circuit to function first. Okay, so this one is a step. Later we see step by step. Okay, this one is one of the part to introduce back what's the forward bias and also the reverse bias. Okay, so you see this part is a reverse bias. Okay, remember the center got depletion layer. When your connection is wrong, you find the depletion layer become further, bigger part. Okay, when I just reverse the battery, they become forward bias, is it? So you see the electrons start to move to fill in the hole. Okay, when they just fill in the hole, that means now the current can be moved. Okay, when the current just start to move, that means they drift. Charge will carry us. So this one we call it as a forward bias. So there's a no problem. The electron and also hole can move easily. So this one called forward bias. Just now they want the depletion layer become bigger part. They want is a reverse bias. So from here I want to introduce forward and reverse because later we're using for the transistor. Okay, now I want to show about the current, how to flow in the transistor. We go through the base circuit first. Okay, step by step. Okay, first one we see the diagram. Okay, base circuit. Okay, let's see the red color part. That one is a current. Inside one, that one is an electron. Okay, we see the connection. Connection, this one is a positive. Okay, this one is a P-type. So P-type join with positive. N-type join negative. So this part is a forward bias. Forward bias means no problem. The electron can fill in the hole. Okay, when it just fill in the hole means the electron will start to move, is it? Okay, then the current can be flow. Now we're going to see the explanation. Okay, first one, when the circuit just switch on, BE, okay, B and base and emitter, junction is a forward bias. This one is the first sentence. Okay, second sentence you must say about the depletion layer. What happened? Depletion layer, they become narrow. Okay, narrow means easy to pass. Then the low resistance. Okay, easy to pass and also become low resistance. So majority electron in the N semiconductor, they flow from emitter to the base. Agree? Because there's a narrow part already. When it becomes narrow part, the electrons start to fill in the hole. That means the electron now is from the N type. N type now is an emitter. They go to fill in the base area. Okay? After they fill in, okay, before that I told you the base area always is a small part. There's a thin part. When they become thin, that means the hole inside the base also become less. Just a little bit hole only. Okay, but the electron is more from the N semiconductor. So you see the C. The number of the holes in the depletion layer decreases. Why they will decreases? Because already filled in by the electron. So therefore, very few electron they combine with the hole. Just a little bit only. So if the hole finish to combine with the electron, what happens? The extra electron, where they want to go? Okay, you see the D. Some of the electron that will flow into the base circuit. So you can see the green color arrow. The electron flow back to the base circuit. Okay, electron flow back to the base circuit. Can you see the direction with the current is the opposite? So from here, there's a normal. Electron flow opposite with the current, then the current start to flow. So electron must start first. Okay, now, after they flow through the base circuit, they still got extra electron. So where the extra electron to go? They say the rest will flow into collector circuit. Okay, they jump to the base already, but they still got extra. The extra, they need to go to the collector circuit. Okay, so that means the electron now they flow to two parts. After fill in the depletion layer, they want to flow back to the base, and last one, the extra one, they want to flow to the collector circuit. Okay, so remember one more thing is electron just start to move. Don't tell me your current stop. The current must be also move, but make sure electron and current in opposite direction. Okay, so this one is how the base circuit to function. Okay, the next one we need to go is a collector circuit. Okay, let's see the diagram here. Okay, they show about the NP and PN. Okay, now you can see about the base circuit. Okay, the base circuit is the electrons start to fill in the hole. Okay, electron extra, they go to the base. Okay, electron extra, they go to the base. Okay, another extra, where they go? They go to the collector. Can you see? Okay, then the collector start to function. So that means the first part, actually collector cannot function. They need to wait the base. Okay, when the base start to drift, so that means the extra electron, they drift over the base and also drift go to the collector. Then the electron start to flow. The blue color is electron. Okay, then the last part, the arrow, the orange color arrow, they start to flow. That one is a current. Okay, so this one is how they show about the transistor to function. Okay, so finally the bulb can be light up lah. So from here, sure is a base bulb to light up first. So later is from the collector part, the current will start to flow, then the bulb will be light up. Okay, so from here, I need to explain how the collector circuit part to function. Okay, just now we go to half story already. The story is extra electron from the end, then jump to the base and also jump to the collector, is it? So that means now the electron, okay, you can see the small arrow. Okay, the extra electron, they will flow to the collector circuit and go to the terminal. Okay, now your more electron, they already start attracted to the collector already. So that means now they will drift the current to start. So when starting, if you know electron, the current is cannot move. Why? Because there's a reverse bias. So from here, electron already start to move it. So your current sure will move also, but in opposite direction. So if the current start to move in opposite direction, means now you got collector current. So the transistor can be functioned. So from here, we go by the words. A, the BC, base and collector junction, there's a reverse bias. So from here, you need to say about the electron cannot flow from the collector to the base. Okay, because you are reverse bias. So the electron, they are attracted across the base to collector. So C is talking about the base just now, the electron extra. From the base, they jump to the collector junction. Okay, after that, they got higher potential difference to collector terminal. Okay, because of high potential difference to attract the electron to come back. When the electron just go through the collector, then the flow of extra electron to the collector from the base, then they produce the collector current. So you must talking about the higher potential difference for the terminal, the collector terminal, they go to attract the electron to come. So when the electron just come from the emitter, go to base and jump to the collector, so the electron start to move, then finally you must say the collector current produced in the collector circuit. Okay, so this one is the whole process of the transistor. So we can say one of the conclusion is no IB, there's a no IC. So that means you must have the base current first, then after that you got collector current. If I say base current is 0, so collector current actually cannot function. Okay, this one is a concept for the transistor. Okay, now we're going to see the working principle of the transistor. Okay, transistor, okay, they can say about the small IB. Okay, the small IB means the base current, they can produce a bigger IC. So just now I told you transistor function is an amplifier. So if I produce a small current for the base, but later collector current can produce higher readings. Okay, when IB becomes 0, that means the IC totally, no need to talk already, they must become the 0 because it depends on the base current. IB and IC not exactly same with the IC because I told you IB is smaller, IC is bigger. Okay, IC sure bigger than IB. Okay, IE is the biggest. Just now before that I show you the arrow, is it? Emitter sure is the biggest part for the arrow because they are collected or the supplier. So IE bigger than IC and also bigger than IB. IB is the smallest one. Final conclusion I can say emitter current actually is collector current plus base current because they're the supply, they also is a collector. Depends for your NPN or PNP, the arrow, how they move it. Okay, so this one is one of the transistor circuit to amplify the current. For you see the emitter first. For the base we using micro emitter. For the collector using milli emitter. Means the base current increase can multiple the current in the collector circuit. Okay, so current amplification, we need to know that because how many types, so we're using this formula. Okay, the changes of the IC over IB. So we know the current, they already increasing how many times compared to the original. Okay. Okay, so this one is just a simple to introduce about the transistor. Okay, the following I will go through to the application for the transistor. Okay, thank you for your